Namaste,
Good,
Joshi sir.
good
Good
evening,
evening.
Professor
sir.
Joshi. How are you?
So kind
Good
of
evening, everybody.
Good
Thank you very
evening.
much.
See, all the students are in place before the
Good evening.
professor joins.
The class is full. Yeah, I was about to say class is full.
Yes. Yes.
At least
Very
even
nice.
from the current numbers, we can always say 50% is full. So that's good sign of the class.
Yeah.
Our
Okay,
students
sir.
are
I think
our students are very disciplined. They come before the professors come in.
Yeah.
Always.
so, gentlemen. I think we should start. And first of all, I would like to welcome you all for the first webinar series being organized by UA NCR chapter. And I thank Professor Joshi to join us, and of course, Dr. Sanjay Mahendra, who is current UA president. And thanks for joining us, Sanjay. And I will request you to say a few words for 5 minutes before we go to Pankaj. Please, Sanjay.
Okay. Good evening, everybody. First, let me congratulate Dinesh and all of you to start this activity at Delhi NCR. When we this new BOG team took over in charge in 2021, we felt that our various chapters are not really active, and we set up a team. Dinesh is a part of a team of a 4 members committee, and with the very clear cut mandate that across the world we will revive the chapters and the chapter activities. Now, what is we why we did that was we felt that if the chapters are active, say across, suppose we have nearly 20-25 chapters across the world, right from California to Singapore. So across the world, there are so many chapters, but the activities of these chapters have nearly gone down. They used to meet once in a while. So reviving the chapter activities was one of the tasks, and Dinesh did this for a couple of chapters in India as well as abroad, and he has been very active about it. So congratulations to all of you to start this kind of a program, because starting a chapter becomes easy, but continuing with the activities and continuing the interest of all the members and bringing them together is not a simple task. But these 4 people, Dinesh, Mr. Raju Panse, Dr. Tippanna, and Dr. Ram Sabnis, these are the 4 guys who were the team, and they have done across the world. In fact, there are 3 or 4 chapters in US. We are very active. There is a now the active chapter in UK. There is a chapter in Pune as well as Ahmedabad, which is what Dinesh has done, and your chapter is also active. So this is one of the really major achievements of UA. And apart from this, of course, we have 2 major programs, which are what we called is our flagship programs. One of the programs is basically we give loans to the needy students every year, and this is one of our flagship programs, and that has been successfully going on for quite some time. Apart from that, we also do the upgradation of our undergraduate laboratories. Over the period of the time, our research laboratories have been upgraded basically because of the help from the corporates also, because they do a lot of projects with us, and that is the reason why these postgraduate laboratories have been upgraded and they are state of the art. But there are a lot of still improvements needed for the undergraduate laboratories, and this was the need which we realized, and we have been doing the upgradation of undergraduate labs over the last 6-7 years. So these are the main 2 programs apart from these chapter activities which we are doing. We are also undertaking now the classroom upgradations in ICT. And so our programs are basically related to in the two sections. One is the upgradation of the facilities within the institute, our alma mater, and the second is related to uh, helping the students, whether starting these loans courses, or we also started two bridge courses for the students. The one bridge course was for the undergraduates, and the another bridge course for the research students. And the idea was whatever is taught in the ICT and whatever is expectations of the industry, they should gel together. So there is some gaps between the two, and to bridge those gaps, we started these courses. And this was again the brainchild of our past president, Mr. Dilip Udas. And he not only conceived the courses but also put together a team of people who can teach into these courses. And they have been very, very, very successful programs. In fact, every year, as soon as we announce these courses, at least 70, 80 students immediately apply for the courses and go through the courses and actively participate in the courses. So that shows these have become a very popular programs. So these are the kind of things which we do. But apart from that, we also want to encourage our past alumni to come together and do these kind of active programs. Uh, I'm sure this lecture from Mr. Pankaj Kejriwal is going to be really interesting. Uh, and something which is being done in the Northeast. Very few companies are there who are doing something. The private companies, there are public limited companies which have been always there, refineries which are always there in the Northeast. But very few private companies have gone to the Northeast and started doing businesses. And this is something really creditable, and this is going to be a really interesting lecture. I just wanted to give you a brief of that is what Dinesh told me to do, what we do in UA, and just talk about that for a few minutes, and before Mr. Kejriwal takes over and tells us a lot of interesting things about his business and his ventures. Thank you very much.
Thank you very much, Sanjay, for kicking it off and taking time to address, uh, on this day, when we start the series. Thank you. We come to Pankaj Kejriwal, who is the Executive Director of Star Cement Limited, a chemical engineer from 1993 batch, started his career from ICB Technocrat, Technimont, Mumbai, and now spent on nearly 22 years out of his 30-year career in the cement industry. Apart from his technocrat portfolio, he has deep interest in logistics performances and also optimize performance, logistics performance optimization, capital markets, renewable and non-conventional energy, business development, strategic planning, and M&A. He is also a member of Research Advisory Committee, RAC of NCCBM, which is National Council for Cement and Building Materials. Over to you, Kejriwal, Pankaj, to take us through to the cement business and technologies, and also to Northeast, I think, which is the of area of interest today. Maybe not for a not a very good reason, but I think that is a very small part of the good big things happening in the Northeast. Please, over to you.
Thank you. Namaste, everybody, my fellow ICTians. And I am thankful to Sanjay ji and our executive committee of the NCR chapter to give me this opportunity to present some lecture or a seminar about the events in the Northeast. I am equally thankful to Professor Joshi and others to join this seminar, and hopefully it will be of interest to everybody. First of all, I would like to know how many of us have visited Northeast. And where exactly in Northeast, sir?
I have been to Assam, Meghalaya. These are the two states at least, not more. I wanted to go to Arunachal Pradesh, but could not.
No, sir, it's really nice. Yeah, where have you been?
Yeah, I have been to Digboy, then this NRL, that is Numaligarh,
Okay.
and Guwahati. So wherever there are refineries, I have been there. Bongaigaon also. So
That's
Northeast was so IOCL was my account when I was in Honeywell into advanced solutions. So all these optimization solutions, training simulators, process simulators. So we used to take all these solutions to IOCL headquarters, and they used to direct us to Northeast.
great. It's really nice to hear. Normally, when we ask this question, people say, yeah, we have gone to Northeast, and they will say either Calcutta or Darjeeling at best. So
Oh, no.
Northeast is there, and for us, Northeast starts after the chicken neck.
Absolutely.
From Assam onwards, the Seven Sisters, that is where the Northeast lies.
Yeah.
So, well, before we go to Northeast, first let us look at the cement industry in India. How is the cement scenario in India and how is it in Northeast? Abhishek, kindly put on the slide. Of course, I would like to say that the Indian cement industry has evolved very well. It is one of the best performing industries in the entire globe in terms of energy efficiency, in terms of environmental controls, in terms of productivity. We are at par with the world. So that is the best part of the Indian cement industry as a whole. If we see today, the current cement installed capacity in the country is about 575 million tons per annum. Though we are the second largest producer in the world after China, just to give you a perspective, but China is at 2100 million tons per annum, way ahead than us. But of course, we are catching up. Currently, our production is about 364 million tons, and we expect to reach 483 by 2028, having a growth rate of around 5%. As everybody is aware, the cement industry is directly linked with other sectors such as infrastructure, construction, housing, transportation, steel, etc. It has a significant role in implementing various government flagship schemes and visions like housing for all, smart cities, concrete highways, dedicated freight corridors, Clean India Mission, ultra mega power projects, waterways. All this is going hand in hand with the cement sector. The growth of the country and the growth of the cement sector, both are hand in hand. Next slide. Still, the per capita consumption in India is still only 240 to 250 kg per capita against the world average of 500 kg. China is again way ahead at around 1600 to 1700 kg. And we in the Northeast, the consumption is still lower than that of the country. We are only at around 142 kg. So this itself shows that there is huge potential and growth still available to the cement industry going forward. Next. This is the typical way where cement is consumed. The major consumption of cement, 60%, is still in the housing sector, be it the rural housing, urban housing, or low-cost housing. Infrastructure still contributes only about 25%. I think this is one area which is growing now on a faster scale. And of course, the commercial and industrial complexes give it another 10%. And if you talk about the cement installed capacity, the major installed capacity is in the south with 33%, north is at 22%, west 13%, center 13%, and east 19%. Next. Of course, as all of us are from the cement, from the chemical technology side, everybody does know about cement, but just to give a brief, cement is a crystalline compound of calcium silicates and other calcium products having hydraulic properties. It was, of course, invented somewhere in 1855, and it was the Portland cement was patented in 1824 by Joseph Aspidin. The main raw materials required for cement manufacturing are limestone and silica. Other than this, we require alumina and iron oxide also, which act as the catalyst. So here the lime comes from limestone or marl, calcite, but primarily from limestone. In some places in Gujarat and all, we are using marl also as the raw material. Silica is available from shale, clay, and again marl, sand. Now, of course, fly ash also to some extent. and alumina is mainly coming from bauxite, shale, clay again. Iron oxide also we take from iron ore or mill scale, and now some blast furnace dust is also being utilized as the raw material for this. Next. The basic process for cement manufacture starts right from mining. So we are basically mining the limestone and the shale, and this is then sent from the quarry to our plant. The crusher is installed either at the mines or at the plant site, depending on the feasibility. The modern way is to install it at the mines, and from there, after crushing, it is conveyed through the belt conveyor to the plant, where again it is stored, and then in the next stage it is homogenized, and after homogenization, we put it through the grinding mills. Next slide. The crushed material is then put through the raw mill, where it is ground into very fine powder. This powder is then blended, and then it is fed to the preheater. And from the preheater, it passes through to the kiln. In the preheater itself, it is calcined to about 98%. In the kiln, where the temperature is around 1400 degrees to 1500 degrees, it forms basically, it's in the molten stage, and it forms the nodules, which is called as clinker. This clinker, we then put it to the cooler, where it is quenched with, it has to be cooled very fast so that it forms the proper crystals. The product coming out of the cooler is called as clinker. This is basically where about 60 to 70% of the entire process is completed. In the next stage, once the clinker is made, we take it to this, again, another grinding mill, where we earlier used to add only clinker and make OPC cement, whereas now we add the fly ash or the slag and make the other kind of blended cement. The cement which is coming out of the grinding mill is then stored in silos. After the silos, we are packing it through automatic packers into bags and then dispatching it to the market. This slide basically shows how the technology has evolved over the past years, and how the cement industry is looking after the various efficiency and sustainability measures. As we can see, before 1980, earlier we were using the wet process kilns, where we had to prepare slurry for the raw material. And because of this, and we were using ball mills at that time. Ball mills, as we understand, have the huge grinding media inside, which are the dead mass which has to be rotated along with the raw material. So this was a huge energy guzzler. The main energy consumption in the cement plant is in these mills. So if you come back. So, and at that point of time, the pollution equipments were also quite primitive. We were using the gas conditioning towers with ESP. All this led to a very high heat consumption of more than 1000 kilocalorie per kg of clinker. Even the power consumption was very high, nearly 120 kilowatt per ton of cement, and emissions were huge, nearly 600 milligrams per nm cube. After the wet process, the dry process kilns came into being, and they came with the preheater along with the calciner. Now this preheater is now typically is going more than 150 meters. That is nearly a 50-story structure. So earlier it started with 4-stage preheater, then it went on to a 5-stage preheater, and now we are using a 6-stage preheater. By increasing the stages, we are basically doing better heat recovery. You can come back to the earlier slide. So as we kept on increasing the stages of preheater, the heat transfer happening between the material and the gas, that improved and leading to better efficiency. Along with the process efficiency of the preheater and calciner, a lot of changes were done on the grinding aspect. Like we came up with the vertical roller mill and roller presses. Now, a vertical roller press mill is like our dosa grinder, where we have a table and we have the hydraulic cylinder rollers above which grinds the material. And similarly, the roller press, that I would equate it to our sugarcane juice mill, where you have two rollers in between where we are passing the clinker, which is, broken down into fine particles. So due to these 2-3 major developments, including now instead of the GCT and ESP, we have been able to install reverse air bag house or pulse jet bag filters. Because of this, the whole scenario has changed. The cement plants are no more a dusty place. Earlier, it was associated with a huge pollution and dusty environment. But now, if we look at the current statistics, the fuel consumption has gone down from 1,000 kilocalorie. Abhishek, you can come back to the previous slide. Yeah, from 1,000 kilocalorie to 820 kilocalories and power to 95 kilowatt. And emission has gone down from 600 to 200. This is prior to 2000. Now, after 2000, things have still further improved, and heat consumption has gone down to 680 kilocalories, and power is also reduced to 60 kilowatt. But the main thing which has helped in this is basically earlier we were using only ordinary Portland cement. Now the world has moved towards blended cement. In blended cement, we are using supplementary cementitious material like fly ash or slag, which is helping us to reduce the clinker factor, and at the same time it is reducing the power consumption, the heat consumption, and everything, leading to more and more efficiency in the process. Along with this, now we have been able to install the waste heat recovery system. Earlier, what was happening, the gases of the temperature of around 300, 320 degree were going out of the preheater. They were a waste of energy as well as causing environmental degradation. Now, with this heat, we have been able to install waste heat recovery systems where we are generating power. This power, if you subtract it from the power consumed in the cement production, reduces the actual power consumption to now 37 kilowatt per ton, which is, if you see in tons of oil equivalent, it reduces it drastically. So the use of blended cement is now being promoted by all governments, and it makes us economic sense also, economic case also, and a very good environmental case. With all the blended cements, we are able to achieve all the properties which were there in the ordinary Portland cement. Rather, some of the properties are better in blended cement in terms of heat of hydration. Those can be controlled in this with blended cement. Now, moving ahead after 2015, keeping in mind the sustainability issues, cement industry is still categorized as a red category industry as per the pollution norms. However, I at a personal level definitely feel a lot of work has been done, and we are again focusing ahead on the circular economy and net zero, based on which it can definitely qualify itself as a green industry in the future. As we understand, circular economy is a model of production and consumption which involves reusing, repairing, recycling existing materials and products as long as possible. The cement industry is working on this on two fronts, using alternative raw materials and using alternative fuels. Basically, we are, if we were making, as you can see in this chart, earlier we were making OPC, that is ordinary Portland cement. So where the clinker factor was 95%, and other material like gypsum and all were added, which used to contribute about 2%, 3% or maximum 5%. That is how we were making the cement. Now from OPC, we have started using other alternative raw materials like slag, fly ash, low-grade limestone, chemical gypsum from fertilizer plants, this Paradeep phosphates, Indian phosphates. They have millions of tons of gypsum lying with them, legacy waste lying with them. Now the cement industry has started using it. Of course, there are issues with it with respect to transportation. Some impurities are there, but that is a very small part of the problem. If you see the overall benefit, it is a win-win situation for everybody. So now the cement industry is working towards using chemical gypsum from fertilizer plants. Also now, as we know, flue gas desulfurization gypsum, we have started making gypsum mostly in power plants to absorb the SOx of the flue gas. So this again is a raw material for our cement production. Currently, gypsum which we were using was mineral gypsum, and that was also being imported from, it is available in Rajasthan, in some parts of the country, but a lot of it is being imported from outside. So when we start using this chemical gypsum or FGD gypsum, it will not only help reduce our imports, but also it's a good environmental step. Along with this, we are also using calcined clay, lime sludge, and red mud. Calcined clay is abundantly available at many places, and lime sludge from paper plants, from other industries. Red mud is a waste of the aluminum industry. All these things are absolutely otherwise they are environmental hazards if left to themselves. As we can understand for fly ash also, there is a huge problem to dispose fly ash. You just cannot leave it anywhere. So it will blow away in the environment. They have to add water to keep it so that it doesn't flow with the air. So when we have started using all these things, it is not only helping the environment, but also has helped us in reducing the cost of cement, also making the cement more greener. Out of this, the first 6 items we are using post-clinker manufacturing, whereas the lime sludge and red mud, we are using it for manufacture of clinker itself. So next. Now this was about the raw materials which we are using alternatively. Now with respect to fuel, this is really a very interesting aspect that we are able to burn any kind of waste of any industry. You name it and we can use it. The cement kilns are so, because of the high temperature profile and everything, we are able to burn pharmaceutical waste, chemicals, municipal solid waste, RDF. You would have heard in between that a lot of Maggie had expired. That was also burned in many cement kilns, FMCG products, plastic waste, biomass, bamboo. All these are the various fuels which we are going to use, and that will help us reduce our coal usage. And thus, we will be able to make a drastic impact on the environment. The next slide. The reason we are able to do this is because the cement kiln is the best incinerator available. The temperature inside the kiln is 1300 to 1400 degrees, which are much higher than any other combustion system. Alkaline conditions in the kiln afforded by the high calcium raw mix can absorb acidic combustion products. The ability of clinker to absorb heavy metals into its structure. All these things, we are able to, with the least environmental impact, we are able to burn the hazardous waste, and everything we are able to dispose in our kilns. Of course, the current TSR, the substitution rate of the Indian cement industry is only 4%, vis-a-vis the world average of around 18% and around 50% of Europe. This is because what has happened is in India, the polluter pay principle is not really being applied. Like if we have to source this plastic waste or the pharmaceutical waste, then that is not our USP. We are unable to do it. Whereas if we get it at our factory gate, then we can very comfortably, use it. So as you can see in this graph also, we are at only 4% and countries in the Europe are nearly more than 50%. Of course, they are slightly more evolved in the sense of collection of waste and all those things. But seeing the government focus now, I think this will most of the cement industry have targeted that they should reach at least 25% by 2030. So that is our target for the using alternative fuels. In fact, many of the cement industries have now registered themselves as plastic waste processing facilities under the PWMR rules 2022, because the extended producer responsibility that we are able to comply not only for ourselves, but for the other industries also. Like the plastic, if it's made available to us, we are able to utilize the calorific value in our kilns. So that is we are able to comply with the regulation also, and also help in the proper disposal of plastics. In fact, we particularly in Northeast, we have used bamboo very effectively for the for generation of as a fuel for power plants. You can show them the next slide for bamboo. you see, we are getting huge quantities of bamboo. Earlier, there were paper mills in Northeast who were buying bamboos. But now, unfortunately, those paper mills closed down. So there is huge availability of bamboo there, which was going waste. So we started tapping those. And then we have a shredder where we convert it into chips, and we are using it in our power plant also and in our cement kiln also. Of course, in power plant, we have been able to convert about 80% of the fuel requirement to bamboo. In cement kilns, of course, we are taking time. I think we have just used about 1 or 2%, but we are putting up the system, and that will also, we want to take it up to 10% of the fuel consumption. Here, I would like to ask one question. Any idea how much does the bamboo tree grow in a day? Any guess?
It could be more than 12 inches as well.
Right. It grows up to 18 inches. Like this was something which I was absolutely not aware. When we started talking to people for bamboo farming and all, now it was also earlier there, but now it has become a household thing in the Northeast, especially in our area where we have the cement plants. People have started growing bamboo in their back gardens. So it has become a source of livelihood, and it is such a green alternative to fuel. So I think it should be promoted very widely. Along with this, now there is a calcined clay cement which this industry is looking at. Because if you see, fly ash currently is difficult to dispose. But over the long term, if we see, the thermal power plants growth is now reducing, and people are moving to the greener source like solar or wind or other things. So eventually we feel that fly ash itself will become a shortage for the cement industry. So to take care of that, we are now developing the LC3 cement, as it is called, where we are using calcined clay. So, and this calcined clay is also available amply in various parts of the country. So this is also a greener initiative, which will also help us to mitigate the shortages of fly ash in the near future. Next. So this was basically what the cement industry is trying to do for the circular economy and net zero. Along with this, most of the cement plants have installed solar power installation right from 10 megawatt to 50 megawatt capacity at each location. So that itself is again, we are replacing the fossil fuel electricity from solar generation. In India, especially, we can see that, we have a habit of having very high productivity standards. When I say VL8, it basically means volumetric loading of 8 tons per day per meter cube of kiln volume. Globally, still people don't go beyond 5 or 6. But here we started from 4, 5, 6, 7, and now people are talking about 8. That means from the same equipment, we are getting the output rates have gone up. This leads to an overall benefit in terms of from the same plant, you are able to manufacture more products. So you don't have to install another plant. It reduces the fuel consumption. It is reducing the power consumption. It is reducing the overheads. So this is again a huge step for this from the sustainability point of view. Along with this, now cement industry has started exploring inland and coastal waterways also for the transportation. Because in cement, logistics is definitely not only a huge cost, it also has a huge environmental impact. So the much more volumes we are able to move by train or further by inland or coastal waterways, that will help us in the overall sustainability initiative. Of course, the newer initiatives of digitalization like IoT and AI/ML implementation, they are at a very native stage, and they will be also growing. And for now, we are talking about carbon capture and utilization and storage. This is also new for the cement industry. And currently, I think it's a few years still away to adopt the technology. Like we were talking in Delhi, there was a plan to install huge receivers which will collect CO2 from the atmosphere to reduce the pollution here. But that again is a very difficult part because the CO2 is well dispersed in the air. It's not concentrated. But whereas in any industry, for example, especially the cement industry also, the flue gas, we have reduced the dust through the back filters, we have taken out the heat in our WHRS, but still CO2 is going out. This CO2 with the new technologies, if we are able to capture it and then, store it, and eventually we will be able to utilize this captured CO2. Maybe one day the cola which we are drinking, in that this CO2 will be used, or this CO2 has various other purposes for various industries. So this technology is now the future technology which everybody is working on, which will lead us, to capture the carbon, waste carbon, and gainfully utilize it. Of course, we are also now working on eliminating coal in its entirety by using electricity for the main calcination process in the kiln. Of course, this electricity should also come from a green source. Then it will become really a green thing. But of course, this is one of the latest initiatives which people are doing. But it is, of course, taking time. And I think the next few years, these are the few things which will help in making the cement industry much more sustainable. Next. So before we move to Northeast, any particular question on cement, or we can take it later on? We can move to Northeast scenario and then come back to cement.
I think you complete the presentation and then we ask questions.
Yeah.
Please.
Okay.
Otherwise, yes, Pankaj, that is what we have already put that in the text box, but certainly after the presentation would be good to take up questions.
Okay, fine. So now coming to Northeast, from basically where we are, as Sanjay ji mentioned that very few private players are there. Of course, the oil refineries have been there. The Digboy has been one of the first refinery in the country, was set up in Assam. So, but to give you a background, we did have our roots in the Northeast. So we migrated from Rajasthan to Northeast maybe about 150 years ago. So that's why we were very comfortable with that area. We knew the local sentiments, and all those things did really help us, to again go back to Northeast and start this cement venture. All of our promoters, we had moved out of Northeast. Of course, I had moved out as a child itself, but the other promoters, they had all moved out from Northeast in the 90s when there were issues in Northeast. And again, in the 2002-3, when the government put their focus on Northeast, we again took the step and we went back there to Northeast. So coming to Northeast, like earlier it was the 7 sisters, but now of course we have included Sikkim also as a part of an economic bloc, and hence we call the 8 states in the Northeast, which are Sikkim, Assam, Meghalaya, Arunachal, Mizoram, Manipur, and Tripura. The Northeast has a total 8% of the country's area and 4% of the population. So, and it is endowed with a lot of natural resources. But the main thing which we should realize is Northeast has the highest international boundary in our country. We are having more than 5,000 kilometers of international boundary when we see all these states combined. We have Tibet there, we have Myanmar, we have Bangladesh, we have Nepal, we have Bhutan. So it's a centrally located area. In fact, Northeast is much closer to these countries rather than Delhi or Mumbai. The aerial distance is much larger if you see coming from Northeast to the main part of the country. Next slide. Of course, Northeast has a lot of places of tourist interest. Right from the Kamakhya temple at Assam, the Kaziranga National Park with the one-horned rhino at Assam. Gangtok is again very beautiful. Cherrapunji in Meghalaya has a lot of waterfalls. Our Tawang Monastery in Arunachal Pradesh and the Hornbill Festival in Nagaland. These are just a few glimpses. The huge opportunities of tourism there. And this map again shows how the various states are connected to the other countries, and the state like Arunachal on the north shares its boundary with China, Bhutan, Myanmar. The major cities in Arunachal are Itanagar and Tawang. Sikkim again shares its international boundary with China, Bhutan, and Nepal, Gangtok being the main capital city. To our right, we have Nagaland again sharing international border with Myanmar. There, Kohima and Dimapur are the main city. Manipur again shares its border with Myanmar, Imphal being the capital city. Mizoram again sharing its border with Myanmar and Bangladesh, and Aizawl is the capital. Tripura sharing the border with Bangladesh and Agartala being the capital. Meghalaya shares its border with Bangladesh, Shillong being the capital. And Assam, of course, has a small border with Bhutan, but and Guwahati, or Dispur as it is called, is the capital, and Jorhat and Dibrugarh are the main cities. Like Dibrugarh, most of us know because of Digboy. They are the adjoining cities. Next. So earlier, before independence, also Northeast was very prosperous area. But after independence, because of the partition of Pakistan, Bangladesh, East Pakistan, the connectivity to the Northeast was limited. It was happening only through the Chicken Neck. Due to this, in spite of having huge resources like timber, tea, and oil, there was a lot of issues with respect to insurgency and low development in the Northeast, which was kind of a black period, from 1970 to 1980, 90s. It is only after in the late 90s, when government again, the Prime Minister Atal Bihari Vajpayee ji at that time, they announced special schemes for Northeast, which eventually led to further development. Like people like us also again went back to Northeast, and we put up plants. Seeing us, various other industries put up plant. Even Dalmia Cement, which is one of the larger players in the country, bought over a plant in Northeast and is now expanding there. So all this has happened because government has given huge focus to Northeast. They have come out with various schemes. For example, the Northeast Industrial Development Scheme, Logistics and Export Policy, Startup Policy, Assam Bamboo and Cane Policy. Some of these are the policy by the central government, and some of these are by the state government. From the next slide, we will see like the central government has offered various incentives, such as central capital investment incentive for access to credit. Basically, it's a capital subsidy for plant and machinery. Then there is central interest incentive. There is central comprehensive insurance incentive, goods and service tax reimbursement, income tax reimbursement, transport incentive, employment incentive. Earlier, there was no cap on this incentive, but in 2017, government has put a cap of 200 crores per unit, which itself is a handsome amount. It's not a small amount, but by any standard. So these are the central government incentives. Abhishek, unka mute kar do na, Suhas ji ka. So along with these central government incentives, we have these various state government incentives. If you see Assam, for example, the SGST exemption is around 150 to 250% of your fixed capital investment. What does this go to show? If you have a product which has a market in Assam, you are getting the entire SGST exempted for nearly 10 to 15 years. And you are getting an incentive of nearly 250% of your fixed capital investment. That means your plant is entirely free. Whatever you are investing, nearly 2 times of that the government is giving you as incentives, the state incentive. Other than this, there is a central incentive which are already there. Of course, SGST is the main incentive for a state. Along with it, you have the small power subsidies, stamp duty reimbursement, subsidy on generating sets, some subsidy on technology transfer and quality certification, assistance for environmental compliance. Now again, they have introduced the SGST subsidy for new and renewable source of energy. If somebody is investing in a renewable source of more than 5 megawatt, there again, the entire investment they will give you back as SGST investment. So the state government and central governments both have made the place very lucrative for the investors. Next slide. And of course, with the overall improvement in the political scenario, their stability, of course, as we were discussing, Manipur unfortunately is passing through a bad phase now. But by and large, the main industrialization has happened in Assam and Meghalaya. These states, Arunachal, they are very peaceful states. Absolutely no worries there. There are some disturbances in few areas of maybe Nagaland or Manipur, but by and large, they are all good. So if you see the state-wise, what are the next slide, the various raw materials there or the key sectors which are operating there. Like for example, Assam, as we saw, we all know that India's oldest oil refinery is at Digboy. It is the largest producer of onshore natural gas in India. Assam contributes 50% of tea production in India. The key sectors in Assam now are pharmaceutical and medical equipment, plastics and petrochemical, power, river transport and port township, information technology, textile and handloom, oils and perfumes. This also could be a very of special interest because agar wood and sandalwood, they have now allowed it to be commercially grown there and used for various industries. So perfumery industry and oil industry are having good potential there. Similarly, if you talk about Arunachal, it has the longest international border. 80% of its forest cover is rich flora and fauna, consisting of 601 species of orchids. A lot of orchids we are importing into the country. And if we develop from here, the cold chain is being developed there. Because of that, orchids from Northeast are now coming to Delhi also. Then there are 622 species of medicinal plants. And it's, of course, home to India's largest and world's second largest monastery, Tawang Monastery. Power, basically in Arunachal, the maximum potential is of hydel power. At one point of time, it was being told that Arunachal can be the powerhouse of the country. Projects of around 50,000 megawatts are under various stages of implementation there. So I think they really have huge potential. Agriculture and forest-based industries, textile and handicrafts, and tourism. These are for Arunachal. If you look at the other states like Manipur, Meghalaya, and Mizoram, Manipur has the highest number of handcraft units and craft persons in Northeast. They are the leading producer of bamboo in India. The Kachai Lemon Festival celebrated every year to promote investment in the crop. Here the key sectors are agriculture, horticulture, sericulture, and bamboo processing units. People have set up tile manufacturing units using bamboo. And eventually, if you see in Europe, people are using bamboo to make fiber. So that is also, and also now we are talking about this ethanol production from bamboo. So the NRL is doing a big project in Assam where they would like to extract ethanol out of bamboo. Meghalaya has one of the finest varieties of turmeric in the country, and it is the third largest producer of strawberries in India. Shillong is the rock capital of India. In fact, all the houses of Shillong will either have a guitar or a drum. And any of these rock star groups which come to India, whether they visit Delhi or no is not sure, but they will definitely go to Shillong. Such is the kind of fan following there. Again, Meghalaya has huge potential for hydroelectric power, agriculture and horticulture, mineral industry, especially cement. All the cement plants of the Northeast are primarily based in Meghalaya because of the ample availability of limestone. And of course, tourism and hospitality is there in Meghalaya. Similarly, in Mizoram, again, it's a very high forest cover and a very huge bamboo production. And again, they are second largest producer of strawberry in India. Wow, that's really nice to know. And then the key sectors again in Mizoram are textiles, fisheries, and agriculture and food processing. Next. The Nagaland has the third highest producer of cobalt in India. I think very few people know. Of course, there are some issues there in mining and all those things, but there's progress is happening there. So in Nagaland, we have cobalt. We have 600 million tons of crude oil reserves. Naga tea, tomato, and Changsing Sol are registered GI of Nagaland. This Bhuj Jholokia. This is the hottest chili in the world. Even if you touch it by hand, sometimes you have the burning sensation on your hand. It's a very small chili, but very hot, and it's the highest hotness factor of chili. So again, the key factors there are, key sectors are agriculture, apiculture, mining, and sericulture. Sikkim is the largest producer of large cardamom in India. It has the highest per capita income among the northeastern states. It is home to 315 glacier lakes and world's third largest mountain peak, Mount Kanchenjunga. The major industries in Sikkim are agriculture and food processing, hydropower, tourism, and pharmaceuticals. Sikkim doesn't promote much of mineral-based industry, but other industries are well promoted there. And lastly, about Tripura, again, it's the 5th largest tea producing state in India, 4th highest literacy rate among all Indian states, and natural gas is available there with 94% methane. So we have bamboo there, tourism, IT, food processing, and technology all developing in Tripura. Next. These are the major brands which are operating out of Northeast. Of course, it has the PSU such as Indian Oil and Numligad. But other than that, if you see Sun Pharma, Hindustan Unilever, ITC, Tata, DS Group, Dalmia Cement, Eveready, the Century Plywood, then we have Imami, we have Orient Electric, Control Print, Eric Life Sciences. I think it's a huge mix of pharmaceutical industries and wood-based industries like plywood. And these are the different industries which are currently private sector industries mainly, which are there in Northeast, including ferroalloy industries. They have also come up there because of the available of quartzite and other raw materials. Next. A brief about our company. Akshay Kumar has been our brand ambassador, and this is our plant there in Northeast. So I think I personally call it as the Switzerland. It's a cement plant in Switzerland. The place is so green and so cool that it's really definitely worth a visit by all of you. So we started this journey. Of course, why we went to Northeast was, of course, as I told you, we had our background from Northeast, and Northeast has the low per capita consumption of cement, and no other cement industries were coming up there. So that gave us the first mover advantage, of course, there. And the best part is one of the best quality limestone is there in the country, is available in Meghalaya. It is available at only 2 or 3 other places in Rajasthan or Himachal Pradesh, which is having a lime content of more than 50%. So we also have in some pockets steel grade limestone. Of course, it has not started coming from there to the mainland because the rail connectivity still needs to be developed. But over a period of time, even that will come from there. So this was the reason a promoter having background of Northeast and huge market was available with no cement player. So we took the plunge in 2003 and we moved to Northeast. We started our journey with a small plant of around 0.4 million tons per annum. And over the years, we have kept on expanding. Currently, we are a 6 million ton company. We have a 12.3 megawatt waste heat recovery power plant. We have a 51 megawatt coal-based power plant. Of course, the usage of coal-based power plant is now going down once we have installed our waste heat recovery. And we expect by next year, we will be a 10 million ton company. When we started this project, even to make a phone call, we had to go 10 kilometers away. That was the kind of, and this was, I'm talking about 2003, 2004, not many years ago. 2003, 2004, no telephone connectivity, forget mobile. So we had to go 10 kilometers, use a WLL instrument, and that's how we could connect every time with our offices across the other parts. Next slide. This in brief shows our capacity, power generation, and we are having a workforce of around 3,100 people. And then indirect employment is to the tune of 15,000 people. So cement industry by and large is a huge employment generator, and of course one of the highest revenue generations for the country. We, at one point of time, the cement industry was the 3rd largest revenue generator for the country. When it was excise duty, we were the 3rd largest excise contributor to the government of India, means the cement industry as a total. Next slide. These are a few of our CSR activities which we focus on: health and sanitation, livelihood development, education and rural development. As a company, our CSR spend is always much more than 2% of the government mandate. In fact, we are targeting nearly 10% of our profits. Eventually, we will be spending on CSR. because we have to do our bit for the society, and it's only when we grow along with our local community is when the company can grow. Last slide. This is again one of our other Star Roshni projects where we install solar seats, street lights, and all those things. Then we have a wildlife and biodiversity conservation project which we are doing in collaboration with the State Forest Department of Government of Meghalaya. So these are few of our activities which we are doing as a part of our corporate social responsibility. Thank you.
Thank you, Pankaj. Excellent presentation. I learned a lot. I don't know about others, but it was very informative and very thought-provoking. I think if somebody looks at it, he should go to Northeast. And thanks for inviting all of us. I think we will try and make a presentation there. Before we, to take other questions, there are a few inputs which is on the chat. Actually, KK is asking, KK, can you ask your question, please?
Sure. Pankaj, first of all, compliments to you for this great presentation. I think really I was also, I think, of the same opinion that I also learned. Though I am not into cement manufacturing, but I'm aware of what process is all about. But certainly very, very enlightening presentation. Two questions, since I look after sustainability in my present role. So my first question is, you talked about alternative material usage. In number of alternative materials. So are you carrying out some sort of life cycle assessment whereby you are finding out in terms of some assessment that how much is the carbon emission or footprint of that particular cement when you are using some alternative material?
See, as I told you, the major alternative raw materials currently being used are post the clinkerization stage. We are using, the clinker, which was earlier used 95%. We have brought down the clinker factor to 30, 35, 40% by using fly ash, slag. So this definitely there's no problem in the life cycle assessment of that. The thing is the raw materials like lime sludge or red mud. There probably we will have to do some analysis on those aspects. Of course, from quality point of view, there is no issue at all in using any of these raw materials.
Okay. And another thing which comes to my mind is these days now alternative materials in terms of substitute of cement are also being talked about. Some lighter, you can say, construction materials in terms of polymeric as well as other things. How do you see that as a challenge for cement?
See, as you rightly mentioned, those are polymeric products. So that again it has to come from either a refinery or it's a natural resource. Whereas in cement, and of course polymer cement is if you talk about cement, it is a 5 rupee kg product or a 6 rupee kg product, and polymers are 80 rupee, 100 rupee a kg product. So really, by when this polymer will be able to substitute cement, and at the same time, cement, if you see, cement means basically clinker. The clinker factor has gone down to 30-40%, and we are using the waste of other industry. So keeping these two things in mind, I don't see polymer as a challenge, at least for the next many decades to come. But of course, science, nobody can predict. But so far, what we see, keeping in mind the cost and the sustainability things, cement has no replacement in immediate sight. Of course, in cement also now we are going for ultra fine grinding of cement. People are working on that. That may again reduce the consumption of cement, or there are other binders people are talking about, which along with cement, some people about reinforced fibers people are trying to add into cement. Those kind of studies are on, and that will go complementary along with cement. So I don't immediately see any change from the polymer technology into this. Like for example, in India, steel itself, steel construction is so expensive than cement. It is nearly 3 times the cost of any steel structure. Whereas internationally, steel and cement go at par, I could say. So because there the labor costs are very different. So as such, cement, I don't see the replacement with polymer, to answer your question as of now.
Okay. Just one last question from my side. It is about emissions. You talked about various waste which you are using for, say, co-processing. So how do you ensure that the emissions are within the emission norms in terms of, say, if those are chlorinated, because I worked in pharma as well. So if those are chlorinated waste and other toxic chemicals are there, how do you take care of the emissions which are there from the cement kiln?
See, those are definitely issues which will have to be addressed going ahead. But keeping the current scenario in mind, and as I told you about the nature of the incinerator and the clinker, most of the pollutants are absorbed. But there are few pollutants which are going out when we use this other alternative fuels. And for that, I'm sure, like we used to have the alkali bypass earlier. So such kind of systems would be developed where these things will eventually be used, because currently the volume of this alternative fuels is very minuscule. So here we don't see any problem, but going forward, as we keep on increasing the quantum of alternative fuel, these things will definitely need to be taken care and will be taken care.
Okay.
Thank you, Pankaj. One question from my side, because in the calcine clay you mentioned, there is in India, all the ores have got lot of silica in it. So is it good or bad for the cement industry, if you use that?
See, we are using silica is required as a part of the cement manufacturing process. So that definitely is not an issue. The issue which we face with calcined clay is that it gives it some color. Unfortunately, color of cement has got no relevance at all to its strength or anything for that matter. But if some people market color of cement also as a USP, there is a general trend of cement consumers to have a darker quality of cement. So even when we started with slag cement, the color was slightly light. Now with calcined clay, the color is slightly reddish. We are working on technologies where the color may not be reddish. So silica is not a problem. The problem is the color associated with the calcined clay, which currently the consumer is being forced not to accept by one of us only. It's a competition which doesn't allow them to use the product. But over a period of time, that will improve, I'm sure.
Thanks.
Pankaj,
Last two questions, Mr. Saxena, please.
Yes.
Yeah,
Dr. Saxena.
Pankaj, good presentation. I don't have a question, but I have a comment to you. From the whole presentation, one slide was missing, which is about the awards. 18 years I was in Ambuja Cement. In fact, whole growth of Secretariat took place during our presence or my presence. So whenever you need anything about awards, we can get it from ministry also, from many other organizations. So if you're interested, just let me know, we'll work on it.
Thank you. So, of course, I definitely missed this slide about our company. We have received various awards.
And it is such a good place. If you see Darlaghat plant of Ambuja Cement, it was resembling with that.
Yes, very much.
Okay. Yeah. And even if you need any effort on biodiversity conservation, I can connect you with WWF, Wildlife Fund for Nature, WRI, Wildlife Resource Institute, Dehradun and other places. Whenever you want, these are all contacts with me. Okay. All the best.
It will definitely be helpful. Thank you so much, because as we keep on growing, we need to further these causes. So we'll definitely look into it.
Sure.
Thank you. Anyone else has any question, or Professor Joshi, if he's there?
He's just reconnecting, I think.
Can I add one more comment here? I was feeling this is waste of time. We are hardly 6-7 people here. Otherwise, it is better to have it in somebody's office with a glass of beer and enjoy that also along.
No, but Dr. Saxena, I think we had up to 20 people. Number one, number two, this recording will go to everybody around.
Okay.
So I think it's a start, and we cannot go by the number here, but of course we can go by the reach on this, because at least people all in the UAE, it was this invitation was sent to all the 6,000 UAE alumni and all the chapters. So and they know this is happening, and this is a start. And I think and of course this information also will go. Professor Joshi, do you want to add something, sir?
Timing should also, maybe suits a certain segment of people.
Yeah, it's a working day. So I also second Dinesh that it is the beginning, and there is a saying also मैं चलता गया, काफिला बनता गया और लोग जुड़ते गए. I think it's a good beginning. I must compliment. I think let's start the journey.
Yes, Dinesh ji has taken huge initiative and got our chapter also is thanks to Dinesh ji and Dr. Tipanna in Mumbai. Because of that, we have started and now I think we will grow surely.
Oh, thank you. Professor Joshi, do you have any comments, sir?
Now I look forward to Dr.
I think he's
Saxena.
on mute.
Good evening, everybody.
Yeah.
Good
Good
evening,
evening,
Are
sir.
you
Doctor.
able to?
Yes.
Are you able to hear me?
Yes, sir.
I was terribly impressed by the lecture. Lot of good information and the progress which has happened in last 50 years. I could see some windows where further progress can be done. Not only for Seven Sisters. Great compliments to the speaker, Mr. Kejriwal, and let us sustain this activity. I'm very happy to be participating in this activity. Thanks.
Thank you, sir.
Thank you, sir.
Honor. Thank you, sir.
Thank you, sir. And thanks to everybody. I think we should close now. And we will keep it going on the next lectures in times to come. Thank you,
Yes,
guys. And
okay.
it's compliment to the whole
Wonderful.
team. Compliment to
Thank
the
you.
whole team and, alumni and Nilesh, Lere, and also Sanket. He did a great job and our CSR. So we should not forget that the secretariat in UAE, who did all the, work to create this, put all the Zoom link and everything around, all the material. Thanks, Nilesh. I think we should, compliment Sanket for this,
Yes,
activity,
definitely.
one way or the
Yeah,
other.
One comment.
And
I
thank you,
thanks to
sir.
Sanjay.
One-
We can't do.
One
Yeah.
comment I
All
see
went
in
very
chat,
well.
Dinesh.
Everything went very well.
Thank you. By Mr. Anil. He has written, for any requirement of funds, let me know. So this is for UA or is it for Star Cement? I just wanted to clarify.
I was wondering.
We will take the offer.
Mr. Anil, can you reply, please? Because nobody can say no to money. Either you. Anil, please. Go ahead. You're on mute.
Yeah. Well, it's for UA as well as for Mr. Kejriwal. I was highly impressed with his presentation and the kind of work they're doing. And in fact, like yesterday itself, our honorable PM was emphasizing the growth and all the factors, what they have changes they have brought in Northeast. So definitely, he's sitting on a gold mine.
Thank you, sir.
It's a
Thank you very
In
much.
case of any
opportunity.
expansion, any this thing requirement of funds will be will help you out. That's what I want to this thing pass on to Mr. Kejriwal. Congratulations. Yeah.
Thank you. And
Thank
we'll-
you.
Yeah.
Nilesh, you want to say something? Maybe vote of thanks.
Yeah. So,
Officially.
official vote of thanks.
So I must introduce Nilesh. He is a secretary of UA.
Yes, we met him in Mumbai during our.
Yeah, but for others, yeah, please.
Yeah. So first and foremost, thanks to our guest speaker today, Pankaj Kejriwal from Star Cement, as well as to Dinesh, who has taken this effort of putting this. I would like to call it a series of webinars. And thanks everybody for attending, Professor JB Joshi and a few other senior members who are here. And I announce that we can close today's session. Thank you.
Thank you. Thank you, everybody.
Thank you very much.
Just a minute. One question. One last question. Mr. Kejriwal, is your company listed now?
Yeah. We are listed company.
Okay. I was not aware. Okay. Thank you.
Yeah.
Thank you so much. Thank you.
Thank you, everybody.
Thank you, Pankaj.
Thank you. Thank you, sir. Thank you.
Good evening.
Nice
Thank
to
you,
see
bye-bye.
Mr. Bang.
Yeah, he has been very active here, Professor Joshi. Mr. Bang is quite active here in our chapter. Thank you.
Okay, bye-bye.
Hi, Atul.
Well done, Pankaj. Bye.
Okay.